Today, we are diving deep into one of the most feared conic sections, the hyperbola. Hyperbolas appear complex and confusing, but once you really understand them, they become surprisingly elegant and beautiful. Hi everyone, this is Akhilanand Singh. In this video, we are going to do a proper exploration. First, we'll clearly define what a hyperbola is, then we will get familiar with all the important terms, formulae and standard equations of hyperbola, and then the main part most of you are here for. We are going to solve three very carefully selected questions that cover some important type of problems you are likely to face in the engineering entrance examination. So grab your notebook and pen and let's finally make peace with the hyperbola. A hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points, called foci, is a constant. A hyperbola is also defined as the locus of a point in a plane which moves so that its distance from a fixed point called focus to its distance from a fixed line called directrix bears a constant ratio which is always more than 1. Let us understand some key terms related to hyperbola. Focus is a point on a hyperbola where light falling on it converges. A hyperbola has two focal points called foci. The midpoint of the line segment joining the foci is called the center of the hyperbola. The line through the two foci is called the transverse axis, and the line through the center and perpendicular to the transverse axis is called the conjugate axis. The points at which a hyperbola intersects the transverse axis are called the vertices of the hyperbola. A directrix is a fixed line such that for every point P on the hyperbola, the ratio of the distance from P to the focus to the distance from P to the directrix is constant and always more than 1. This ratio is called the eccentricity of the hyperbola. A hyperbola has two directrices, each associated with one of its two foci. The directrices of a hyperbola are located outside it and are perpendicular to the transverse axis. Eccentricity measures how much a conic section deviates from being circular. For a hyperbola, the eccentricity is always greater than 1. The rectangle in the center of the hyperbola whose diagonals are the asymptotes is called the central rectangle or the fundamental rectangle. Sides of the central rectangle are of the length 2a and 2b who are parallel to the transverse axis and the conjugate axis respectively. The word asymptote originates from the Greek word asymptotos, meaning not falling together. Asymptote is a straight line that continually approaches a given curve but doesn't meet it at any finite distance. Asymptotes are the straight lines along the diagonals in the central rectangle of the hyperbola. Branches of the hyperbola approach these lines but never intersect them. Let us talk about some standard equations of a hyperbola. The standard equation of a hyperbola when the center is at the origin and the transverse axis is along the x-axis is x square upon a square minus y square upon b square equals 1, where a is the distance between the center and the vertex and b is the distance between the center and the co-vertex. There is a Pythagorean relation among the constants a, b and c, which is c square equals a square plus b square, where c is the distance between the center and the focus. When the hyperbola changes its orientation so that the center is at the origin but the transverse axis is along the y-axis, the equation of the hyperbola becomes y square upon a square minus x square upon b square equals 1. The Pythagorean relationship among a, b and c remains the same. The standard equation of the hyperbola becomes x minus x1 whole square upon a square minus y1 whole square upon b square equals 1 when the center is at the coordinate x1 y1 and the transverse axis is parallel to the x-axis. Here also the Pythagorean relationship among a, b and c remains the same. In this slide you can see the formulae for the latus rectum and the eccentricity and also the equations of the directrices and the asymptotes of a standard hyperbola. A latus rectum of a hyperbola is a line segment perpendicular to the transverse axis passing through either of the two foci with endpoints lying on the hyperbola. This slide has the formulae related to the tangent to a hyperbola. In this section of the video, we solve some questions related to hyperbola. The first question is, if E1 and E2 are the eccentricities of a given ellipse and a given hyperbola, and E1 E2 is a point on the ellipse 15x square plus 3y square equals k, then k is equal to 14, 15, 17 or 16. Let us find out. Here the equation of the given ellipse is x square upon 18 plus y square upon 4 equals 1. It can be written as x square upon 3 root 2 whole square plus y square upon 2 square equals 1. Hence, a equals 3 root 2 and b equals 2. We know that in an ellipse, the Pythagorean relationship among a, b and c is c square equals a square minus b square. Hence, c is under root 18 minus 4, that is under root 14. Applying the formula of the eccentricity c upon a, we get E1 equals root 14 divided by 3 root 2, which equals root 7 upon 3. Equation of the given hyperbola is x square upon 9 minus y square upon 4 equals 1. It can also be written as x square upon 3 square minus y square upon 2 square equals 1. Hence, a is equal to 3 and b is equal to 2. The Pythagorean relationship for a hyperbola is c square equals a square plus b square. Hence, c is equal to under root 9 plus 4, which is equals to root 13. The eccentricity of hyperbola is also c upon a, which turns out to be root 13 upon 3. The question states that E1, E2 is a point on the ellipse 15x square plus 3y square equals k. Substituting the value of E1 and E2, we get 15 multiplied by root 7 upon 3 whole square plus 3 multiplied by root 13 upon 3 whole square equals k. Solving it, we get the value of k as 16. Hence, D is the answer. Let us move on to the second question. It was asked in the IIT JEE Mains examination 2026. The question is, the equation of an ellipse is x square upon 36 plus y square upon 16 equals 1. A hyperbola confocal with this ellipse has the eccentricity of 5. If principal axis of the hyperbola is x-axis, what is the length of the latus rectum of the hyperbola? And there are 4 options given to choose from. Let us solve it. Equation of the ellipse is given, which can be written as x square upon 6 square plus y square upon 4 square equals 1. Hence, a is equal to 6 and b is equal to 4. In an ellipse, c square equals a square minus b square. Hence, c is equal to under root 36 minus 16, which is equal to 2 root 5. It is stated that the hyperbola is confocal to the above ellipse. It means the value of c is same for the hyperbola and it is 2 root 5. It is also mentioned that the eccentricity of the hyperbola is 5. But we know that for a hyperbola, eccentricity is equal to c upon a. Substituting the values of e and c in this equation, we can say that 5 equals 2 root 5 upon a. Solving it, we get the value of a as 2 upon root 5. For a hyperbola, c square equals a square plus b square. Substituting the values of c and a in this equation, we get 2 root 5 whole square equals 2 upon root 5 whole square plus b square. When we solve it, we get the value of b square as 96 upon 5. Knowing the values of b and a, we can use the formula of the latus rectum of the hyperbola as 2b square upon a, from which we get the latus rectum as 96 upon root 5. Hence, a 96 upon root 5 is the answer. Let us solve our third question, which was asked in the IIT JEE Mains examination 2025. The question is, latus rectum of a hyperbola x square upon 9 minus y square upon b square equals 1 subtends an angle pi upon 3 at its center. If b square is equal to L upon m 1 plus root n, where L and m are co-prime numbers, what is the value of L square plus m square plus n square? We begin by extracting the value of a from the equation of the hyperbola, which is x square upon 9 minus y square upon b square equals 1. From this we get the value of a as 3. Mn is the latus rectum of the hyperbola shown on your screen. We know that the latus rectum of a hyperbola is 2b square upon a. So mf is equal to half of the latus rectum, hence it is b square upon a. Substituting the value of a in it, we get mf equals b square upon 3. It is given that the latus rectum Mn subtends an angle pi upon 3 at the center. So the angle MOF is half pi upon 3 radian, which is equal to 30 degrees. In the triangle MOF, tan 30 degree equals MF upon OF. Substituting the values of tan 30 degree, MF and OF in this equation, we get 1 upon root 3 equals b square upon 3c. Hence c is equal to b square upon root 3. We know that in a hyperbola c square equals a square plus b square. Substituting the values of c and a in this equation, we get b to the power 4 minus 3b square minus 27 equals 0. This is a quadratic equation in the variable b square. Solving it for the roots of b square, we get b square equals 3 upon 2, 1 plus root 13, discarding the negative root. It is given that b square equals L upon m, 1 plus root n, where L and m are co-prime numbers. Comparing it with our equation b square equals 3 upon 2, 1 plus root 13, we get L equals 3, m equals 2 and n equals 13. Hence L square plus m square plus n square equals 182. Therefore, option A, 182 is the answer. That's all for this video. Your feedback as comments will be highly appreciated.